In this video, we're going to talk about section 3.5, which is recursive data structures. So we're essentially going to extend our idea of recursion to some applications in computer science. We're also going to use some inductive proofs to show that common recursive functions actually work as they should. So we're going to start with lists. So in section 3.2, we looked at the idea of a mathematical sequence. We said that a sequence was a list with commas, so some a sub 1, a sub 2, a sub 3, and so on. And say we have some a sub n, the subscript n indicated that the a sub n is the nth term of the sequence. Now a sequence is ordered. A sequence is also different from a set in that the terms can be repeated. So the fact that a sequence can repeat elements and also has this kind of ordered structure to it makes it different from a set. So remember that a set is an unordered collection of objects. So we don't allow repetition, but the order also doesn't matter. So if an element is already in a set, we don't need to add it in again. But remember, we have stuff like the Fibonacci sequence. So the Fibonacci sequence was, of course, 1, 1, 2, 3, 5, 8, and so on. So note that both the first and the second terms are 1. Since this is a sequence, not a set, that's allowed. So in computer science, a list mimics the mathematical idea of a sequence. A list is a set of data elements in some sequential order. So we have some x sub 1, x sub 2, x sub 3, and so on, where all of these x sub I have the same data type. So for instance, if you wanted to list the students in a class, say you had Sam, Miller, Lisa, Richard, another Sam, Wilson, Stephanie, and Morgan. Note that the name Sam appears twice. The order also matters. So Sam is the first in the list, and Lisa is the third item in the list. Now note that those Sams are most likely different people, which is why we want to include them both. And because this is a list, it's a sequential order of them, we can allow both of them. Now the commas are part of the structure of the list, and they're actually highly important. So if you think about changing the orders of the commas here, say we had this. So let me just write it out really quick. So note that technically I just wrote the same thing that I wrote above, but I just have some less commas. But note here, now I technically have Sam Miller, Lisa Richard, Sam Wilson, and Stephanie Morgan. So this list, as stated, is technically 4 people. Where that's not going to be the same as essentially my original list, which once we add in those extra commas again, we suddenly have more people because we're saying that each person is essentially separated by a comma. So this original list would be 8 people. So the positioning and the amount of commas actually really matters here because the amount of commas essentially tells us where we break up each kind of element of the list. So if we only have 3 commas, that only gives us 4 things in the list, whereas if we have 7 commas, we have 8 things. So we need to be really careful to make sure that the commas are a part of lists that we write. So let's think about writing a grocery list. Now, it might seem a little silly to think about it in this way, but if you're writing a grocery list, the first thing you have to do is actually write down the first item. And then essentially you have a list. Lists don't need any more than 1 item. And then you essentially add on the next item to a list you technically already had. So you start with the first item, that becomes a list in and of itself. Then you add the next item, well now you have a list of 2 items. Well then you add the third item, well now you have a list of 3 items. And you essentially just tack on an extra item to a list that already exists. So we can actually think about lists in a recursive fashion. So the recursive definition of a list is the following. Let X be a set. A list of elements of X is going to be essentially X, where X is in X. So little x is in the set X. And then we can have some L, comma, X, where essentially X is in your set and L is a list of elements in X. So essentially you have a list already and you just tack on a kind of last item at the end, kind of like this grocery list idea. You already had a list and then you thought of something else to add on at the end. So note that the comma is part of the definition of the list. Remember, they're highly important. So we're going to use the comma to separate the items on the list that we already had and then this new list that we built by tacking on this last kind of item at the end. So let's use the recursive definition to build the list Sam, Miller, Lisa, Richard. And then we're going to state the part of the definition that we use at every step. So we have to start with essentially creating the first item on the list. So we have to essentially add Sam onto the list. So note that Sam, Miller, Lisa, and Richard are all kind of part of our set of things that we're pulling from. So we can start with Sam. And this is essentially just from the base case of the recursive definition because we took something that was in the set of things we could pull from. So Sam was essentially in the list of names we had to choose from, so we can go ahead and put it on the list. Well, now Sam essentially becomes its own list. So now we're going to tack on something to the end of the list that we already have. So we're going to have Sam, comma, Miller. And that's going to come from the recursive step because essentially we took the list, Sam, and added on an extra element, Miller. Well, now we want to add on Lisa. So we take the list that we already had. We already have Sam, comma, Miller. That's essentially the L in the recursive definition. And then we can tack on this last element of Lisa, also by the recursive step. And then we have one last thing we need to add in. So we take the list that we already had. So Sam, Miller, Lisa is now the L in the recursive step because once we do the step again, we rename the things. So this is our list that we started with. And then we add on, comma, Richard. And that is, again, by that recursive step. So that might seem a little silly because we're just creating a list and it might seem pretty obvious, but it's kind of following this very obvious pattern of you start with one thing that is in the set that you're working over and you're just adding in elements as you go along. So this is how we would use the recursive definition of a list. So the idea of a list will appear in computer sciences with things like linked lists, stacks, etc. So lists do show up a lot when it comes to having a list of elements, of course. So we're going to end this video here. We're going to go over the idea of a sum function in the next video.